Welcome back. So now we'll get onto the short-term effects of cardiovascular and respiratory systems within football entirely. So this won't be a certain movement. Most everything between the cardiovascular and respiratory systems, Ricardo and Maria will back up. As we get onto the respiratory system, just give a little base. So there's certain aspects to the respiratory system. So you've got the nasal cavity. This will inhale the air. The pharynx. This is the passageway for the air to lead to the trachea, which we'll get onto in a sec. The larynx is the voice box. So I'm using my larynx now to talk. The trachea is the rings of cartilage which keep the windpipe open. And it's lined with fine hairs called cilia, which filter the air before it reaches the lungs, so it takes away all the intoxications within the air. The bronchi is next, and these are two branches which reach down from the trachea into the bronchioles and the lungs. The bronchioles are the smaller branches leading from the bronchi, which go into the tissue and the air sacs. And finally, the alveoli is the functional respiratory units where gaseous exchange happen. So gaseous exchange is most effective when there's a large surface area. A thinner membrane allows quicker gaseous exchange. Well supplied with blood capillaries and moist lining enables gas to dissolve easier. So when it comes to, say, football, there's inspiration and expiration. This is where the diaphragm contracts and relaxes. And then, so inspiration is when the ribs move up and out, making your chest really big. And then expiration is when the ribs return to the rest state. Most footballers would have an increase in inspiration and expiration after a long period of time, so not short term, because of the more oxygen they can bring into their muscles. So we'll get on to the cardiovascular effects now. So to begin with, the acute responses, you have the breathing rate. So this is normally between 18 and 80 breaths per minute. It's active in the tissues and the muscles, so the oxygen will reach them to get rid of lactic acid. The aerobic system will use energy to get rid of the CO2 because it needs more oxygen to get rid of the lactic acid and other things. There's two ways breathing rate occurs, and this is when the joint receptors pick up certain aspects. So when the footballers are exercising, the sign goes to the medulla oblongata, which is basically a trigger to stimulate the respiratory muscles, and this will help increase the oxygen going into the muscles to get rid of the lactic acid. Or you see controlled breathing, and this is constantly taking breath, which overrides the automatic. So when you see footballers, say, taking a free kick, and they've needed to take in more oxygen due to the neural way, they slow down their breathing to calm themselves before taking the spot kick. Furthermore, you have the chemical control, and this is where the receptors detect CO2 within the body, and it sends a signal again to the medulla, stimulating an increase in breathing rate, as a more brief way of saying it. But this is obviously when lactic acid builds up because of the exercise you're putting in, and it helps prevent fatigue. Tidal volume normally is 0.5 litres to 4.5 litres a time. So tidal volume is the amount of air inhaled and exhaled in one breath. So therefore, most footballers now will have a higher amount of tidal volume than an average person would be, because of that extra amount of oxygen intake and the amount they need to get rid of the lactic acid, as they're constantly training and constantly fatiguing whilst performing exercise. So also a larger thoracic cavity will allow more air. So again, this will mean that most footballers will be able to get more air in because of a larger thoracic cavity, because this holds the air. They'll have a more unit of storage for the oxygen within their bodies. A chronic cactation, so this is long term, so this is getting more in depth about what will happen over time, which the footballers will mostly have instead of the acute responses, because they've probably been playing it most of their lives. So you have an increasing capillarization of alveoli. This helps get the oxygen purified and helps move it through the body. The hypertrophy of respiratory muscles. Hypertrophy is where the muscle gets bigger and stronger. So the respiratory muscles will get bigger and stronger to help the process allow more air and quicker air to occur within the body. So gaseous exchange will occur more quickly, more bronchioles, more air will be inhaled through the nasal cavity, etc., etc. The vital capacity will be increased. So as I said, the footballers will have a larger vital capacity, and due to the fact that they've been doing exercise for prolonged periods of time. An increase in VO2 max, so this is where the oxygen is transferred to the body and utilized through the working muscles in 1 minute. So this is where the oxygen, how efficient the oxygen is at getting rid of the lactic acid basically within the muscles. And finally, minute ventilation, and this is where the breathing rate is times by the total volume. So as we know, the tidal volume and the breathing rate both increase in acute ways. So if footballers have been playing this for prolonged periods of time, this will mean that the minute ventilation overall will exceed successively. So finally, we'll get onto the energy systems within football. So when playing football, there are many adaptations to movements during the game. This is backed up by Riley and Thomas. They found that player movement changes every 5 to 6 seconds and sprint every 15 meters. However, Ohashi and Dapoor suggest that compromising sprints is 3 to 5 seconds, so there is a bit of contrast and there is rest between 30 and 90 seconds. So as for the energy systems of ATP, PC, anaerobic glycolysis, and the aerobic system, 75% of 90 minutes, average BPM is 157, so 157 beats per minute. So this is, according to Riley and Thomas and Smaros, so down here, that this is really important for the aerobic system. So the aerobic system suggests that 3/4 of the playing time is jogging and walking at moderate intensity, whereas sprinting suggests that an aerobic glycolysis is there but not working that hard. So it suggests that ATPC is the more important of all of those two anaerobic systems, according to Smaros. However, all three systems are present in football, according to Nagahama and Apor. So we already know that aerobic and ATPPC are involved, but anaerobic glycolysis was a tricky one. But according to Nagahama, this is apparent, and Apor backs this up as well. However, Ekpalm suggests that the different standards of football, so from elite to non-elite, or non-elite to elite, will change the effects of the energy systems, of course, how the ability they play, how long they run for, what they do in the game, so more sprints, more rests, etc., etc. So furthermore, Ohashi supports the theory of movement by suggesting 70% of distance is low moderate pace and 30% is running / sprinting. So that's similar to Riley and Smaros by saying that 75% of the game is walking and jogging. So, and then the ATPC and anaerobic glycolysis will contribute to the high intensity etc., etc. Riley also found, 1.5. Riley also found links between VO2 max, and Smaros supports this by claiming VO2 max relates to higher amounts of sprints, providing aerobic system importance. So therefore, going back to the acute responses and the long-term responses, Smaros backs this up by saying that VO2 max is important for footballers. So ATPC is the main way, really, according to these people, to do this. So ATP stands for adenosine, and the P stands for phosphate, so it's adenosine triphosphate overall. This is one source of energy, and to get the energy, potential energy, the bonds in between the APPP is energy. So ATPase is the enzyme that breaks this down for this energy to happen. So the energy is released, and when this has occurred, ADP is released, so adenosine diphosphate, and this leaves adenosine with 2 phosphates instead of 3. And then ATP, as we already know, 0.3 seconds activity. So this does link to where Apor and Ohashi suggested that 3 to 5 seconds is the main way. Of which, when this occurs, lots of ADP has been used, so we can't use this energy anymore. So this is where PC comes in. So this is phosphocreatine, and then you got a bond for phosphate and a bond for creatine, and the bond is the energy. The enzyme to break down this is creatine kinase, and this is 3 separate elements. So it will be ADP plus P, and the P is the phosphate plus the energy, what was left from the ATP, and this will leave ATP plus C. So creatine is left, and the creatine, when we're recovering, so after the sprint, the creatine will rejoin the phosphate to rebuild PC during the rest periods because of the blood capillarization, getting the oxygen, etc., to the working muscles and things like this. But the energy does need to re-synthesize, so this is known as coupled reaction. This is the process of the products from PC to get to ATP again. So anaerobic PC is 3 to 10 seconds long, so variables can change. So gender, males will have larger stores than females. Supplements will allow larger stores, and PC is increased because of byproducts, so lactic acid, etc. Next, in a sec, we will get on to glycolysis and the aerobic system. So anaerobic glycolysis is when there's insufficient oxygen, so carbohydrates are used for this. So this is why you see most footballers eat carbohydrates before games. So glycogen, there's bonds: glycogen, glucose, and pyruvic acid. The enzyme to break glycolysis to glucose is glycogen phosphorylase, and then the enzyme to break glucose and pyruvic acid is an enzyme called phosphofructokinase. This breakdown gives us 2 ATP. So obviously we know ATP gives us the sprinting stuff, and then pyruvic acid goes to lactic acid. To break this is lactodehydrogenase, and this is 10 seconds to 3 minutes of exercise. No glycogen plus glucose can't occur. Contractions worsen when the enzymes denature due to this lactic acid. So overall, different positions and standards will affect this. So goalkeepers won't use the ATP method as much, because if the standard of football is, and their team's higher than the rest, because they'll be standing around more often, whereas strikers will often sprint more than other, and midfielders will sprint more than others, so the ATP will be most useful for them. But overall, as you can tell from support and backed up ideas, aerobic system is the most important energy system of this of football. Thank you for listening. And here are the references for this project.